So essentially, I think Annie has set me up beautifully, right? We're thinking in the context of the research that our team has been working on blood pressure and hypertension. So it's a huge public health risk problem. And as she kind of set up, right, these are really complex diseases where population level, there's so many things going on, both from the genetic standpoint and from the lifestyle standpoint. All this is kind of coming together. And so our work is kind of using metabolomics and interactions with other omics data to try to understand these pathways to disease, to try to kind of identify, as she set up beautifully again, interventions and targets, right? So that's kind of the focus and kind of what drives a lot of the work we've been working on. So I was going to start first with some work that we've done looking at just kind of understanding how blood pressure is associated with both the gut microbiome and with the plasma metabolome in Chinese adults. And so basically we have this population cohort covering several different provinces and megacities in China. And so we've really kind of captured kind of this age range of 30 to 69. And one of the big kind of strengths of kind of being able to look at metabolomics in China is there's a really high rate of undiagnosed and untreated hypertension. So when we're looking at these, as she beautifully again pointed out, right, medication is such a large role. And so we're able, it gets a little bit complex to try to look at metabolomics and microbiome in the presence of medication. And we kind of had this opportunity for a very unmedicated population to look at hypertension. And as you can see here again, right, we had a small group, a smaller subset that we had the microbiome data collected on. And then we had the untargeted metabolomics from the Metabolome platform. And then you can see there's kind of this small overlap that we were able to get just based on consent and those type of things. And so we definitely did kind of interest. I'll talk a little bit about what we did with those overlap. So I'm going to touch briefly. So essentially, we didn't see a lot of individual genus in the microbiome that was associated with blood pressure, but we did see these notable between person differences. So kind of in this overall measure. And so what you can kind of see here, visually, the easiest one to kind of see was this like fourth principal coordinate, if you're familiar with those, where essentially, right, we see kind of this separation, and the colors are a little bit hard to see, but here's kind of that highest rate of hypertension is up here, and kind of the lower ones are right down here. And so we're kind of seeing the separation across blood pressure based on this pattern. And this pattern was associated with this bacteria, which is really, as you know, as we're kind of thinking through this type of bacteria is often involved with the production of TMA, and so like precursors of TMAO. So it is kind of helping us kind of link these two together. And then in terms of metabolites, so that was kind of just microbiome, and here's kind of our just metabolites. So I have several of these figures to illustrate. Essentially, I think looking at individual compounds can get a bit overwhelming in terms of our results. So we've kind of summarized these in terms of pathways. And so what you'll see here is on the x-axis here, this is the log FET. So anything to the right of that dotted line is significant. Anything to the left is not. And then the size of the dots are the enrichment factors. And so that's essentially saying if we have more compounds than we would expect by chance, that bubble is going to be bigger. So these are those 8 pathways that we found evidence of differences across blood pressure, both SBP on the left and DBP on the right. And so I'll touch base on that a little bit. The other thing we looked at is we were kind of looking at accuracy in terms of predicting blood pressure. So both SBP and DBP, this is the root mean squared error. So essentially how well can we predict? And while this axis might make it look a little bit like there's differences, there really weren't a lot of differences. And so essentially we're seeing pretty comparable prediction of blood pressures, you know, regardless of kind of these host factors, metabolites, and microbiome that we put in here. And again, this is on this small subset of the 355. So again, I would take that into account as we're thinking about just the variation that we might not be able to capture here. And so again, in that overlap group, we did try to look at basically any of the metabolites that we found, the individual compounds that were associated with blood pressure. we were looking to see how correlated they were with the that pattern of microbiome that we saw. And so again, like we didn't see too many, there's kind of these 3 that we saw. But again, I think when we were thinking about large scale components and the large amount of variation, I don't think we were totally surprised. We were hoping for a little bit more, but we kind of see some of these patterns, you know, suggesting there is some type of linkage there. And so from this work, right, we're seeing in this untreated population, we do see differences by the microbiome for those with higher versus lower blood pressure. And we did see a lot with lipid patterns, right? And so several of these metabolites kind of fall into this sphingomyelin, phospholipid, and I'm sure I'm going to say all these wrong, so please forgive me, phosphatidylcholine and phospholipid. So they were positively associated with SBP and DBP. And so essentially all of these kind of align. And I think, again, as Annie set up, right, a lot of these, even though, you know, these lipid patterns, we didn't see a lot with the compounds, we definitely think from the literature and from biological knowledge, we know these are associated with the gut microbiome. So this all really does kind of fit together. But essentially, right, we were with that 355, it's really hard with the amount of variation we see, especially across, you know, several different provinces, to really narrow that down. So we kind of consider this a first step in understanding those. So one thing that to kind of bring it back to the Metabolome Symposium, so of those 8 metabolomic pathways that we found in the untargeted, 5 of those were available in the complex lipid target panel, which Heino will talk about later. So we essentially have kind of these broad things we've kind of been able to narrow it down. And we are interested, we kind of said, like, let's go back and look at kind of these specific pathways with absolute concentrations and better understand this from a really research driven and not as much of an exploratory question. And so, yeah, so basically we're going to start looking at these same things in a different population. So our team has written a grant looking at kind of longitudinal metabolomics in the CARDIA study. So this is Black and white men and women aged 18 to 30 at baseline. Sorry, I didn't correct that. And then we're having metabolomics collected at this visit down here, year 20 and year 35. So they're older, we're kind of getting into the point where they're developing hypertension. And we're able to kind of look both longitudinally at risk factors and at the metabolomics here. And so we really kind of, from this, one thing that was of interest to us was, can we replicate these associations that we saw in these untreated Chinese adults in Black and white US adults? So that was definitely of interest here. And then I think to kind of get at, again, what we're kind of focused on is, can we kind of identify these things on the causal pathway? So not only can we look at those cross-sectionally, but also are these same compounds going to be linked with like the risk of incident hypertension in the future? And so just as a kind of heads up in terms of what we're talking about, so as you can see, right, there's been some different definitions and updates to hypertension. We're focused really on these 2017 guidelines. And so we're looking at those. When I'm talking about hypertension, I'm talking about greater than or equal to 130 or greater than or equal to 80. So the good news is we found these same type, right? These pathways were still really important here. So this was wonderful news for us. We were excited to see it. And again, there's 83 compounds that were associated. So this was a lot. And again, a lot to show here. A great thing for a table and a paper, but maybe not for a presentation. And so here again, you'll see the pathways. So here I've kind of separated the phospholipids are kind of those top ones that have the asterisks. And then here are the sphingolipids down here. And so essentially, right, we found 2 of the phospholipids that were associated with SBP and DBP. So again, this is that cross-sectional at year 20. And you can see kind of these dots here on the right. And then these 3 are kind of those ones we saw for the sphingolipids. So as a reminder, right, I think it's a little bit tricky. These are 2 of the pathways that we found in the Chinese adults. And these kind of pop up here as well as really important. But we also found these additional 3. right? So 1 phospholipid and 2 sphingolipid groups that were really unique to the CARDIA cohort, but are kind of related in this larger broad pathway here. And so then, as I mentioned, we are looking at these associations between baseline values for these compounds and 15-year changes, and looking at how they're associated with incident hypertension, with the idea that this spans, right, 15 years, there's a lot of changes, not just in the in the metabolomics, but also in lifestyle and just aging in general. And so, as I mentioned before, right, in CARDIA, we found 83 compounds. 15 of those were also associated with longitudinal things. So here it's a little bit, I'm trying to put probably too much on a slide, but I just kind of wanted to illustrate all of these were positively associated with hypertension. So these first 2 columns are for a fold chains, what increase in SBP and DBP do we see? And then the last 2 are for the odds ratios. I've blacked out, or the ones are white if we didn't see a significant result after adjustment for multiple comparison. So these candidates in particular, we feel like this is really strong evidence in terms of understanding the phenotypes to say, these we think potentially there's something going on here that's kind of leading to this. These are very robust findings. We're really excited about kind of moving these 15 forward in terms of thinking through the next steps. And then I was going to say, these are not highlighted, but essentially too, I think this is those pathway results for change. And so here on the left, you'll see baseline, and on the right, you'll see change. And so really what we're seeing here, the boxes didn't, but here's these 2 that didn't pop in our SBP and DBP, but we're seeing some signals for them for incident cases. So again, like the wonderful thing about CARDIA is we have this really rich, not only data between those 2 time points, but also data leading up to that. And so that's something we're really excited about kind of investigating. Is there something kind of different about these? So essentially, I think we were really excited about replicating these associations that we saw in 2 different, really different cohorts. So one is, right, they living in China, Chinese adults, unmedicated, and we're seeing some of the same signals in these US Black and white adults. And then there's a lot of these compounds specifically kind of from these 3 groups where we saw kind of these really robust findings. And we're really interested in kind of better understanding that and linking to that, because those were the ones associated with both incident risk as well as cross-sectional. And then these 2 groups we were kind of excited to see were associated with prospective hypertension, but weren't associated with cross-sectional. And so I think we're really interested in kind of understanding that a little bit more. The good news is, right, our findings are pretty much in alignment with a lot of these other studies that are showing a lot of association between these compounds with hypertension and with other cardiovascular diseases. There are a lot of hypothesized ideas about kind of the pathways through which these operate. Some are really unique to each of these compounds and these groups. This one is just kind of one example of the sphingolipid pathway. And so as you can see, right, it's impacting a lot of things that we kind of are on the pathway to hypertension for many people, but there's also a lot of heterogeneity. And so we are really excited about in these large population scale cohorts being able to investigate this, with the fact that we think there's lots of people that are kind of getting to hypertension via different exposures and risk factors and just things there. And I will say, like, the other good news is some of the stuff we found, so those 2 groups that we found that were associated with perspective but not cross-sectional, we did see, you know, recent evidence is kind of pointing to some of those same things in other population-based cohorts. So we're kind of excited about that. And a lot of the work has been focused on ceramides, which is one of the sphingolipids. But, you know, as I said, work is kind of expanding, I think probably with the help of folks like Metabolome, who are having this targeted panel and are understanding other players kind of within that group and the role they might play. And again, I was gonna say, Annie set me up so beautifully, right? The goal of this is really, can we identify some upstream targets for prevention and treatment of hypertension? And we feel like kind of going from this broad spectrum to this narrower targeted panel provides some really valuable insight here. And then again, our future work, so as I mentioned before, Carrie North, who's here, is doing outstanding work with our team to kind of look at the genetic data. So we have genetic data on all of the CARDIA participants and all of the CHNS participants, or a lot of them, I should say. And we feel like incorporating that into this is going to really help us, especially kind of given this, you know, broad variation that we're kind of seeing in these, where it's not as a controlled small study. And then that is it. I want to thank the CARDIA and China participants. And then I was going to say, this is a small subset of our team, several of whom are from Metabolome, but just wanted to thank them as well. And then I don't know, do you want to say anything about Jeanette? Okay. So we were, well, more is to come, and we're excited about that.